Okay, so we ended yesterday talking about graphing equations. And we had equations that looked like y equals negative 2/3 x plus 4. And when we graphed those, there was a starting point. Then from a starting point, we did a rise and a run. So for this equation here, y equals, we go up 4. And that point right there is where we start this graph. From there, what do we do? Perfect. We have the slope as the number that multiplies x. The top of the numerator is the rise. It's a negative 2, so we go down 2. And the denominator is the run. So it's a 3, so we go over 3. That right there is our second point. Now this here really isn't there. I can take that out. My line just goes through those 2 points. But then we ran into equations that had things like this. Y minus 3 equals 1/2 x minus 2. The equation had to be y equals for us to graph it. So what did we have to do that in order to be able to graph it? We have to get y by itself, so we're going to add 3 to get rid of the negative 3. Now remember, when we add or subtract, we only have to add or subtract to one digit on each side of the equation. So we added 3 to the negative 3 to cancel it out, so we're going to leave the y alone. But we have to add 3 somewhere on the right side as well. Well, we cannot add 3 to 1/2 x. We can only add the 3 to the negative 2. Over 2 again, if that made us feel better about having another point, since those first two are kind of close together. So there's our line. Or we might have (4y) equals 8 minus 3x. I have to get y by itself, so what do I have to do? Divide by 4, since y is being multiplied by 4. When I multiply or divide an equation, I have to do it to every piece, every digit. So 4y is a digit. I divide it by 4 to get rid of the 4. I have to divide by 4 over here. 8 divided by 4 is 2. And my negative 3x divided by 4? Negative 3/4 x. Good. 2 right there. And then the slope is perfect, negative 3/4. So we go down 3 and over 4. So there's our second point. So our line goes through those 2 points. Like that. Well, we kept going with that. And we ran into equations that looked like this. (3y minus 1 equals 2x plus 5). Now we still have to get y by itself, but here we have to get rid of the 3 and the negative 1. Which one do we get rid of first? Negative 1. So how do we get rid of it? We add 1. So it's gone, leaving us with 3y. And when we add or subtract, we only have to add or subtract. 3y gets divided by 3. 3's canceled, giving us y. Equals 2x divided by 3 is 2/3 x. And 6 divided by 3 is 2. So when I go to graph that, where do I start? Positive 2. And from there I go up to over 3. There's my second point. If I want to, I can do it again up to over 3. So my line goes through those points. Or I might have something that looks like this. Three x minus 4y equals 8. And again, we have to solve that for y. It has to be y equals. I have to get rid of the minus 4 is multiplying y, and the 3x has been added. So to start solving it, I do what? I subtract the 3 right here, I divide by negative 4. 8 divided by negative 4 is negative 2. Negative 3x divided by negative 4, positive 3/4 x. Very good. So now to graph that, we start at the negative 2. And from there we go up 3/4. So right there's our second point. So our line goes through the points. Like that. Any questions? How do I graph y equals negative 3? Start at negative 3, and my slope is 0. So 0 means it's a flat line, a horizontal line. Well, that was a slope of 0. What if I have x? It's undefined slope, or non-existent slope if you prefer to put it that way. Because it's straight up and down, there is no slope. The run is 0, and you can't have 0 in a denominator. So there is no definable slope for that equation. Okay, as promised yesterday, we're going to go the other direction with these, where I give you a graph and you define an equation. Then plus or minus a y-intercept. Well, the easiest part to find here is probably the y-intercept. What's the y-intercept here? Positive 3, right there. That's where it crosses that y-axis. It's a positive 3, so you put plus 3 here. Now the slope is going to take a little bit more work. We find 2 points that we can identify. That point right there, and then here's a point we can identify. And the slope is defined by this triangle. So the rise is going down how far? 1, 2, 3. So it's a negative 3. Our run is 4. 1, 2, 3, 4. So that means the slope, we use the letter m to abbreviate slope for some reason, is negative 3/4. So what goes in here is a negative 3/4 times x plus 3. We might have one that looks like this. What's my y-intercept? Negative 2. I crossed the y-axis there at negative 2. So that means this is minus 2 at the end. Then what multiplies x is my slope. 1, 2, 3. So the slope is 2/3. So this is y equals 2/3 x minus 2. And I tell you that out here, it goes through a point 8, 8. But with that point out there not on the axis, it's a little bit hard to draw in that right triangle for the slope. But what we can do is look at the points. This point is x equals 0, y equals 6. That's 0, 6. And this is 8, 8. Which of those coordinates, the x or the y, describes the rise, the up and down? The y does. We're going from 6 up to 8 in the y. So that makes a rise of 2. Of course, then the run is described by the x-coordinate. We're going from 0 here to 8, so that makes a run of 8. So we have a slope here, a rise of 2 and a run of 8. That'll reduce to a 1/4 slope. It's best if you do, but no, you do not have to. If you leave it as 2/8, that's fine. Now, looking at what we had there, we could have got that slope just from the points. Because in our slope, remember it's rise over run. The rise was the difference in the y coordinates. I'm going to write that as y2 minus y1. And the run was the difference in the x coordinates. I'm going to write that as x2 minus x1. So if I have 2 points, like I had there, I had 0, 6 and 8, 8. I can label them point 1 and point 2. Find my slope. y2 is 0.2, the y coordinate. That's 8. Minus y1, that's 0.1, the y coordinate, which is a 6. x2 is 0.2, the x coordinate is 8. Minus, what's x1 going to be? 0. 0.1, x coordinate is 0. So 8 minus 6 is 2. 8 minus 0 is 8. So 2 8s, or again, I can reduce it to 1/4. So if I know any 2 points on the line, I can find its slope. I might have -3, 7 and 6, -5. And if I want to find the slope of this, I'm going to call this point 1 and point 2. Remember, slope, the -5. Very good. x2 is 0.2, y2 is 0.2, the y coordinate, that's the -5. Minus, what goes next? +7, good. y1 is 0.1, the y coordinate, so that's 7. So -5 minus 7 is going to be our rise. So for our run, what goes first down here? The 6. x2 is 0.2, x coordinate of 6. Minus a -3. x1 is the 0.1, x coordinate would be -3. So we've got to be careful with our negatives. -5 minus 7 is -12. 6 minus a -3, remember that's the same as 6 plus a +3, or 9. So my slope is negative, but I'm still going to reduce the numbers. 12 and 9 both divide by 3. Give me 4 and 3. So it's a -4/3, or -4/3 for my slope. Any questions? I'm going to try one in your notes. So if I give you 2, 12, good. That becomes 7 plus a +5. On bottom, -6 minus 2, -8. Now again, we look at that as a positive divided by a negative. Our slope is going to be negative. Then we reduce the 12/8. Both of those can be divided by. So I want you guys to try to graph for me. (2x minus 4y equals 4). I want you to rearrange that into y equals top one. Where's that one going to start out at? Positive 1. So right here. And from there it's going to go up 3 over 4. So my line goes through there. Where's that second one going to start out at? Positive 6. Good. And from there it's going to go down 1 over 2. And I'm going to go a second time. Down 1 over 2. And I can see that point overlaps. Well, remember we said we're looking for the point that solves, it's set, that is that x equals 4 and y equals 4. So the point 4, 4 satisfies both equations. If I put it back in, put in 4 for y and 4 for x, and I reduce those equations, I'm going to get the same result on both sides. Let's do this one. I put in 4 for y, 3/4 times, I put in 4 for x. 3/4 times 4 is 3, so 3 plus 1 is 4. So that's true. For this one, put in 4 for y, put in 4 for x. Negative 1/2 times 4 is a negative 2, plus 6 is 4, so that's true. Have we do that? Yeah. There. What's that? Yeah. Like I said, in this class, we're not going to do that. I mean, that's the next step. But if you were to go on business math or math to business applications, doesn't require that. It goes right up to that, but then we kind of veer off into more financial calculations. But if you were to get into more of a managerial problem solving, there's a lot of cases where there's systems of equations. You have to satisfy both at the same time. If you had to take tech math, depending on what program you're going in, you'd have to be able to do that. I'd say about 2/3 of the math classes you would take after this one would require that. Math with business applications actually starts out very similar to the first couple weeks of this course. Fractions, decimals, and ratios and proportions. But then the last 2 units, the second unit is invoicing, markups, markdowns, trade discounts and stuff like that, cash discounts. And then the third unit is investment, compound interest, annuities, payments on a loan, and things like that. You do a lot of algebra, but you don't necessarily graph anything. Okay. Well, that's pretty much all the new topics for the week. Anybody have any questions? Okay. Well,